Welcome dear student and Jai Swaminarayan. In the previous video, we were discussed about the average speed and the average velocity. How we can calculate the average speed, how we can calculate the average velocity, that all the things we were discussed in the previous video. Now dear student, suppose a car is starting from the one point, traveling a distance 100 kilometer in a 2 hours, right? A car is starting from the one source and travels a 100 kilometer distance in a 2 hour. So what will be the average speed of the car? Of course, the average speed of the car is 100 divided by 2. That means the 50 kilometer per hour. Is it means that the car start with the speed of the 50 kilometer per hour and reach to the destination? No. It's a speed, maybe a increase. It's a speed, maybe a decrease at the sometimes at the one point. From the starting of the car, initially the speed of the car is increasing to the certain limit. If the traffic is more, the speed of the car is a decrease. So the average of all the speeds, right, is called the average speed of the car. So dear student, from the average speed we cannot know the what is the speed and the velocity of the car at the particular time, right? So for that we will understand the instantaneous velocity and the instantaneous speed. So dear student, today in this topic we will discuss the instantaneous velocity. What do you mean by the instantaneous velocity? What do you mean by the instantaneous speed? We will discuss. So here the average speed tells us how fast an object has been moving over a given interval, but does not tell us how fast it moves at the different instant of the time during that interval. So here dear student, the average velocity or the average speed tell us about how fast the car is moving from the one source to the destination in a given time interval. What is the average velocity or the average speed of the car? So here the average speed or the average velocity tell us how fast the object moves in a given time interval, but it does not give us the velocity or the speed at the different instant of the time. So for that we need to define the instantaneous velocity. The velocity at the instant of the time is called the instantaneous velocity. So here the velocity at an instant of the time, that is called the instantaneous velocity, is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. So here the if we consider the time interval between the two instant of the time is a very small. How much small? Infinitesimally small. Infinitesimally small, that means the time interval between the two time instant 3 and 3.5 3.0000001, infinitesimally small. That means the time interval is a very small. It is near to 0 but not 0. In the maths it will be taking as a limit of the resolution of the time interval. So the time interval is infinitesimally small. The average velocity is called the instantaneous velocity. If you consider the two time instant, time t is equal to 3 second and the time t is equal to 3.0000001, right? So the time interval between these two instant is a delta t is a 0.000001. We can say that it is the time t is equal to 3 seconds. So as the instantaneous velocity is the velocity as the limit of the average velocity, as the time interval delta t is a very small, so the velocity at the instant, that is called the instantaneous velocity, is defined as the limit of the average velocity as the time interval delta t becomes very small, infinitesimally small, and it is denoted by instantaneous velocity v is equal to limit delta t tends to 0. Limit delta t tends to 0. What is the meaning of this limit delta t tends to 0? Delta t tends to 0, that means the time interval delta t is a near to 0, very close to 0 but not 0, infinitesimally small time interval, and the average velocity is a displacement divided by time, that is the delta x divided by delta t. So in the maths, this limit of resolution is denoted by a differentiation, dx by dt. Here the d by dt is called the differentiation of the position with respect to time. So what is the differentiation? We were discussed in the chapter number 0, topic number 5, right? So if you don't know the what do you mean by the differentiation, how we calculate the differentiation, see the chapter number 0, lecture number 5 for the differentiation. So here we use the differentiation of the position with respect to time gives the instantaneous velocity at the any time. So dear student, here v is equal to limit delta t tends to 0 is the limit of resolution of the time interval delta t tends to 0. Here the time interval delta t is a very small, right, infinitesimally small, and the delta x by delta t is the average velocity. So the instantaneous velocity, by the definition of the instantaneous velocity, is defined as the limit of average velocity as the time interval delta t is infinitesimally small. We can write instantaneous velocity limit delta t tends to 0 delta x by delta t, or in the mathematics this is called the dx by dt, where the symbol limit delta t tends to 0 stands for the operation of taking a limit as a time delta t tends to 0 delta t. Here the delta t tends to 0, that means the value of delta t is a very close to 0, near to 0 but not 0, that is called the limit delta t tends to 0. Now this whole the things limit delta t tends to 0 delta x by delta t. So if we calculate the average velocity between the t equal to 3 second and t is equal to 3.000001 second, it is a instantaneous velocity at the t is equal to 3 second, right? So here the dx by dt is called the differentiation of the position x with respect to time t. So to calculate the instantaneous velocity, we take a differentiation or derivation of the position with respect to time. So dear student, if you don't know the derivation or a differentiation of the any physical quantity with respect to other physical quantity, see the previous video of the chapter number 0, topic number 5, lecture number 5 regarding the differentiation. That is the what do you mean by the differentiation, what are the rules of the differentiation, how we take a differentiation of the any physical quantity with respect to other physical quantity. Or we can say that differentiation, that means the rate of change of position with respect to time. So here the dx by dt is the rate of change of position with respect to time. So the rate of change of position with respect to time gives us the instantaneous velocity at the time t, or the instantaneous velocity at the time t is the differentiation of the position with respect to time t. So dear student, understand about what do you mean by the instantaneous velocity and how we can calculate the instantaneous velocity. So let us see the how we can calculate the instantaneous velocity. Instantaneous velocity is the velocity at the instant of the time, right, at a particular instant of the time. Or we can say that the instantaneous velocity is defined as the limit of the average velocity where the time interval delta t is a very small. So let us how we can calculate the instantaneous velocity using a graphical method, and how we can calculate instantaneous velocity with the calculation method, right? So first of all, we understand the instantaneous velocity using a graphical method. So here for that, consider a position time graph for the motion of the object, right? So consider this position time graph for the non-uniform motion of the object. What do you mean by the non-uniform motion? Yes, the distance traveled by the object is unequal in an equal interval of the time. We can say that the motion is a non-uniform motion. So consider the position time graph for the object moving in a straight line with the different speed, right, with the different velocity. So the different distance covered by the object is unequal in a equal interval of the time. So consider this position time graph, right? For finding out, if we want to find the velocity at the time t is equal to 4 second, right? So how we can calculate the instantaneous velocity at the time t equal to 4 second? So for that, first we take a point p1 at the time t equal to 3 second and at the time t equal to 5 second. Draw these 2 points. Select these 2 points, t equal to 3 second and t equal to 5 second. Point P1 and P2 on the graph and draw a straight line joining the point P1 and P2. So now if you find out the slope of the line P1 and P2, it is the average velocity of the object during the time t equal to 3 and the t equal to 5 seconds. So we can easily calculate the average velocity of the object by calculating the slope of the line P1 P2, right? So if you calculate the average velocity, but it is not an instantaneous velocity at the time t equal to 4 second. We cannot say the velocity at the 4 equal to t equal to 4 second is the average velocity between 3 and 5 second, right? So now reduce the time interval. So in the first case we take a time interval 2 second, t equal to 3 to t equal to 5 second. Now reduce the time interval, we take a 2 point 3.5 second and 4.5 second and calculate the average velocity. It is close to the instantaneous velocity at t equal to 4 second. Now again reduce the time interval t equal to 3.7 and t equal. So as we decreasing the time interval, we can close to the instantaneous velocity at the t equal to 4 second. Now take a time interval t equal to 4 second and t equal to 4.00001 second and draw a line at a t equal to 4 second. It is intersect the curve at the t equal to 4 second at the 1 point and it is called the tangent to the curve. So the at the velocity at the t equal to 4 second is the slope of the tangent to the graph at the t equal to 4 second. So the slope of the tangent at the any point in the xt graph gives the velocity at the t equal to that point, right? So t equal to 4 second. So if you want to calculate the velocity is equal to t equal to 4 second, draw a tangent to this curve and calculate the slope of this tangent gives the instantaneous velocity at the t equal to 4 second. So the slope of the tangent at the any point in the xt graph gives the velocity at that point. So if we want to find the velocity at the t equal to 5 second, draw the tangent to this line t equal to 5 second and calculate the slope of this tangent. It is the velocity at that point. So here, dear student, we can calculate the instantaneous velocity using a graphical method at any instant of the time by drawing a tangent and calculate a slope of the tangent at that point. But the graphical method to calculate the instantaneous velocity is not convenient in all the case, right? So for that we take a calculus method for calculating the instantaneous velocity at the given point. So in the calculus method we use the equation of the instantaneous velocity v is equal to dx by dt, where d by dt is called the differentiation of the with respect to time. So the differentiation of the position with respect to time give us the instantaneous velocity at that time. So how we can calculate the instantaneous velocity at the instant of the time or average velocity from the equation of the position? Let us understand with the help of the example. Example number 3.2 given in the textbook. The position of an object moving along the x-axis is given by the x is equal to a plus bt square. Right? Here the equation of the position is given to you. The position of the object is given by the equation x is equal to a plus bt. So any equation is given to you of the position where a and b is a constant. Value of a is a 8.5 and value of b is a 2.5 meter per second square. Here instantaneous velocity can be found with the help of the differential calculus method. The differentiation of the position with respect to time give us the instantaneous velocity. According to the formula, v is equal to dx by dt. Instantaneous velocity at the time t v is equal to dx by dt. So just put x instead of x d by dt, we put a equation of position a plus bt square, a plus bt square. So differentiation of this d by dt of a plus bt square. For the differentiation, see the lecture number 5 of chapter number 0. So here a is a constant. The differentiation of the constant is a 0. So need not write. Here b plus b is a constant and the differentiation of the t square is a 2t. So we get the equation of the velocity v is equal to 2bt. Now put the value of b is a 2.5. We get a equation of the instantaneous velocity is a v is equal to 5t. Now we want to calculate the instantaneous velocity at the t equal to 0. Simply by putting a value of t in this equation, t equal to 0. So instantaneous velocity at the t equal to 0 we can get by putting v is equal to 5t in the v is equal to 5t, t equal to 0. We get the velocity at the time t equal to 0 is a 0 meter per second. And the instantaneous velocity at the t equal to 2 seconds. So if you put in a v equal to 5t, if you put t equal to 2 seconds, we get 5 into 2, we get the velocity at the t equal to 2 seconds is a 10 meter per second. So dear student, understand how we can calculate the instantaneous velocity at the any instant of the time. Instantaneous velocity can be calculated with the help of the differentiating a position with respect to time. V is equal to dx by dt. So if you differentiate the equation of the position with respect to time, we get the equation of the velocity. And in the equation of the velocity, if you put a instant of the time t equal to 0 second and t equal to 2 second, we get the instantaneous velocity at the instant of the time. Now how we can calculate the average velocity from the equation of the position, right? So what is the average velocity? Average velocity is the final position minus initial position divided by time interval, right? So position at the t equal to 4 second and position at the t equal to 2 second, right? Because we need to find the average velocity between t equal to 2 second and t equal to 4 second. So first we calculate the position at the t equal to 4 second and position at the t equal to 2 second. x4 minus x2 divided by 4 minus 2. Now x4 we take the here t equal to 4, we get a plus b into 4 square, that is a 16b. So x4, the position at the time t equal to 4 second is a plus 16b. Or instead of this we can put a value of a and b also. We get the position at the x equal to t equal to 4 second, right? And similarly x equal to 2 second, we get the position x4 and x2, and from that we can calculate the average velocity between these two. A cancel out, 16b minus 4b divided by 2, we get a 6b, right? Now value of b is a 2.5. So if you put 6 into 2.5, it is a 15 meter per second. So we can calculate the average velocity during a t equal to 2 second and t equal to 4 second by a change in the position divided by time interval, right? x4 minus x2 divided by 4 minus 2, right? x4 is the position at the time t equal to 4 second, x2 is the position at the time t equal to 2 second. So if you put the values in this equation, we get the average velocity. Dear student, see here the instantaneous velocity at the 2 second and the average velocity between 2 and 4 second is not same. Similarly, you can calculate the velocity at the time t equal to 3 second, 4 second, any instant of the time by the equation of the instantaneous velocity. Similarly, dear student, if any equation of the position is given to you, equation of the position in terms of the time is given to you, and you want to calculate the instantaneous velocity, we need to differentiate this equation of position with respect to time. We get the equation of the velocity, and in this equation of the velocity put the instant of the time, we get the instantaneous velocity. Now to calculate the average velocity, we calculate the two final position and the initial position, and the average velocity is the final position minus initial position divided by time interval. So for the any equation of the position, we can calculate the instantaneous velocity as well as the average velocity with this example, right? So dear student, I hope that you understand what do you mean by the instantaneous velocity and how we can calculate the instantaneous velocity using a graphical method as well as using a differential calculus method.